Today we're going to take a look at the quadratic function in factored form, and we will learn how we can use the factored form of a function in conjunction with the vertex form of a function in such a way that they kind of help each other to give us the right information needed to either solve a word problem or graph it or so on. Now, in this case, the problem revolves around the Dufferin Gate at the west end of the Canadian National Exhibition in Toronto. This gate is a parabolic arch that is approximately 20 meters tall and 22 meters high. Now, for the purposes of this exercise, it's something that I have made up. I said that the arch is located 1 meter east of Lakeshore, which is considered 0, 0. So if I would graph, that would be my graph. And this would be 0, 0. The Lakeshore the arch starts 1 meter east, means to the right, starts at 1 meter east of the Lakeshore at x equals 1. Now, the problem tells us that the Dufferin Gate is 22 meters wide. Well, if I have to go 22 meters towards the right, I will stop at 22 plus 1. I will stop at 23. Now, I want us to stop and think a little bit about what number 1 and number 23 on the x-axis represent. What do we call those points where the line intersects the x-axis? And if you have answered the x-intercept, you are correct. So the x-intercepts are 1 and 0 and 23 and 0. Well, we know that in the factored form of a function, the generic form is y equals a x minus r x minus s, where r and s were the x-intercepts we also call them roots, or you might hear people talking about them as zeros, from the fact that the y-coordinate for that point is 0. So if r and s are the x-intercepts, and for the Dufferin Gate the x-intercepts are 1 and 23, let's see if we can replace those numbers and start filling in our equation. So y equals a x minus 1 x minus 23. Now let's think about the next clue that is given to us in the problem. The Dufferin Gate, the arch, is approximately 20 meters high. So if I would think of it as a ceiling, so if this is 20 meters, that's the height, this is the ceiling of that gate. The gate cannot pass the red line, right? Like that's how tall it is. Now, we might call it that that's the maximum height of the gate. Now, I want you to think now about the vertex form of a function. And when we heard the word maximum or minimum, what did we usually think of? And if you have answered vertex and vertex form, you are correct. The vertex, which is given by P and Q. So the vertex form of a function is y equals a x minus p squared plus q. Now, that maximum height of 20, what value or what letter in the vertex form do you think it represents? Does it represent the A, the P, or the Q? Well, let's think about it. In that vertex point P and Q, which letter gave us the maximum value of a function? And it was Q. So I know that my Q is 20. Now I need to find the P. Well, I know that a quadratic function is represented by a parabola which is symmetrical, and I might not do a very good job at drawing it overly symmetrical, but I'm going to try, where that's my vertex, which right now has the coordinates P and 20. Now the parabola, we know that is always symmetrical, and I apologize for the lack of symmetry in my drawing. I'm not the best freehand drawer, but we know that the parabola is symmetrical. Whatever I have on the left side, I will have on the right side. And the axis of symmetry was given by the x value in that vertex form, by the P. Now, how would we be able to find the P when all I know is the two x-intercepts on either side of that parabola? So let's look at the x-intercepts on the screen and figure out how we can find P. Well, the distance from 1 to the middle, knowing that that parabola is symmetrical, should be the same distance from the middle to the 23. So how would we find this middle point? Well, if we average the two x-intercepts, so 1 plus 23 over 2 equals 24 over 2, which is 12. So this point is 12. That represents the x value in the vertex or the P. So that is my P. So it's 12 here. Now, I have the function in two forms. One is in factored form over here, and one is in vertex form over here. The one value that remains to be found is the value of A. Let's think how would we be able to find it. I know 3 points in my parabola. I know the two x-intercepts, and I know the vertex. Well, we learned in a previous lesson that if we substitute a point back into the equation of the function, we could find the value of A. Now let's think about what point we have to choose for which form of the quadratic function. In the factored form, if I choose one of the x-intercepts, what's going to happen to my whole expression? Or if I choose 1, the first bracket is going to become 0, and then A will disappear. So I can't use any of the x-intercepts in the factored form. So the point that I want to substitute in the factored form is the vertex of 12 and 20. And in the vertex form, I can use any of the x-intercepts, meaning 1 and 0 or 23 and 0. Once you substitute, you will find that A, the value of A, is negative 20 over 121. And we should have known that A is a negative number from the beginning because my function is opening down and has a maximum point in that parabola. The next lesson will formalize the steps of converting the factored form of a function into vertex form, or finding that vertex point from the factored form of the function.